Hello and welcome to Fuzzy Logic Designer plugin for Unreal Engine. In this video, I will introduce the plugin for you and how to use it. But keep that in note that I will assume that you already know what Fuzzy Logic is, how to design a simple Fuzzy Logic controller, and you already know the terminology of it. The terms like linguistic variable, fuzzy set, implication, rules, fuzzification, and all that kind of stuff. If you don't know, I added some links in the description. They are really short tutorials on it, and it's not something hard to grasp. I definitely recommend you go and check them. That videos are also how I learned it. So if you already know, let's proceed with the introduction to plugin. All right, so to teach you how to use it, I will go from an example case, and in this case we want a cube, in this particular cube, to grow when player gets closer to it and shrink when player gets far away from it. So yeah, this can be also issued with some simple linear equations or curve mapping, but the same logic that we are going to do right now can be applied in a more complex systems like a big game economy where you want the prices in the shops to be changed depending on the player's stats or a more complex AR behaviors. But yeah, for the simplicity, we will just use a simple case like this. Okay, so first of all, you open your content browser, and if you right click to it, you will see that we have new a kind of asset named Fuzzy Logic System in both gameplay and artificial intelligence submenus. They are same, there's no difference, so you can pick whatever you want. And we will name them as FLS underscore name of the system, and I will pick it as tutorial. And yeah, when you first open your Fuzzy Logic system, you will see that there are 5 main views. On the left side, we have the elements. On the right side, we have the good old details panel. In the middle, we have plots and rules view. On the left bottom, we have a small log window, which will tell you that your system is fine or there's something broken about it, you need to fix it, and all that kind of stuff. Alright, so in our system, we are going to have two linguistic variables, one for the distance between player and the cube, and the other one for the scale of the cube. And the distance is actually the input variable, and the scale of the cube is the output variable, because we are providing a distance to system, and the fuzzy logic system does some calculations and it provides an output of scale. So yeah, let's start creating them. To add new variable to system, on the left side on the elements view, we have our layers, and you can click on them. And when you click on them, you can right click, and from the context menu, you can add variable, or you can directly press Ctrl 2 to add new variables to selected layer. And you will see that they came with fancy names, and you can change them by clicking on them and pressing F2, or right click and select rename. You will notice that when we click some stuff on the elements view, we start showing something on the plots view, and also the details view change depending on your selection, the elements view. You can select multiple things on the elements view, and both plots view and the details panel will respond to your selection, and same will go for the rules view, but we don't have any rules right now. And right now, the thing that we are interested is the intervals of those values. For distance, we would like to consider an interval of 0 to 3000. And for scale, we want a scale between 0 and 2. And let's save it. And after we made our change for the linguistic variable, let's keep going with adding our fuzzy sets. We can select a variable or both of them together or multiple of them, and right click and add fuzzy set. Yeah, we can add two fuzzy sets to both our linguistic variables, and they will also come with their own fancy names, so we can change them. So distance can be either close or far, and scale can be small or big. One thing that I should note, there are some restrictions on the name of the elements in here. So for variables and fuzzy sets, you can only use alphabetical characters. So you cannot use spaces or numbers or some other characters. Only alphabetic characters are allowed for the names. And yeah, and after that, we can define our fuzzy sets. On the details panel, you will see that we can choose various types for the membership function, and the case of the membership function will be shown in here. So for close, I will choose an Z-shaped function. From 0 to 500 will be fine. And for the far, I will choose an S-shaped function from 0 to 500. And you can change the colors of them. I'll pick a blue color for far and a red one for the close. So you will see that now our plots view starting to make some sense. And also in here you can left click to plot itself to simulate a crisp value for the linguistic variable. As you can see, when I move my mouse, the distance value, the crisp value changes, and I can observe the memberships of each membership function. So at a distance of 140, our closed membership is 0.84 and far membership is 0.16. And yeah, let's proceed with defining the memberships for scale. In here, I will choose a linear z-shaped function from 0 to 1 for small, and linear s-shaped function from 1 to 2. Nah, I don't like this. I'll just pick this kind of setup, and same goes for in here too. One thing that you will notice, the plots view will show the thing that you will probably want to see in here. So if you select a fuzzy set, it will show its the owning linguistic variable. If you select the variable itself, it will of course show the variable. If you select the layer, it will try to show all variables in the layer. So if we add a new variable in here, you will see that the plot of it will be shown in here too. And also you can select multiple things. So if I select these fuzzy sets, it will show the parents of those fuzzy sets in here. And yeah. After we set up everything, we can start defining our rules. And for this simple system, I will only have two rules. To add rules, you can select the layer you want to set as the input for the rule and right click and press add rule. And also you can do the same thing by Ctrl 4. And you will see that now we have this rules view in here, and this title will say that my inputs are from the input layer and outputs are on the output layer. This will make sense if we have multiple layers in here, so we can have some rules from input layer to layer hidden layer 0 and from hidden layer 0 to output layer. And in here you can also right click on the rules itself and click add rule for quickly adding rules of the at the layer that this rule is already contained in. And you can select multiple of them and right click, remove, or just press delete on your keyboard and you will delete the rules. On the left side of this rule, you will see the number of it, and there's a text box for defining the rule expression. On the right side, the weight of the rule, which determines how much this rule will affect the outcome of the system. And we can start defining our rules by simply typing them, and our rules are if distance is close, then scale is big. And for the second rule, if distance is far, then scale is small. And yeah, that's it. After defining our system, all we need to do is on the toolbar menu, you will see bake system. We can click on bake system and the log will say everything is okay. We have two layer, two variable, four fuzzy set, and two rules, and we are good to go. And for demonstrating how this log view can be useful, let's say we made a typo and instead of writing big, we write bin. And you will first notice that syntax highlight will try to tell you that something is wrong. But if you miss it and try to bake it with that, you will have a compile error in the log view and it will say there is no file set with label bin in linguistic variable with label scale. So you may notice your issue in here. And yeah, let's make it again. Okay, before actually connecting this system into the gameplay, I would like to test what have I done so far. So to test it, we can open the tools menu and in here with the debug, we have the fuzzy logic system inspector. And this is a really powerful inspector tool. And it's something standalone. It's not depending on the asset editor, but yeah, you can just dock it with the asset editor in here. And on the left side, you can select a system asset, which is FLS_tutorial in our case. And you will see there's some graphs in here, and also we have this crisp value mapping in here. What you are seeing on the left side of this view is you are seeing your rules as graphs, as the way that fuzzy logic is interprets your linguistic rules or expressions. And you can simulate the input or the crisp value for your inputs in here, and you will observe the outcome. At first row, you will see our first rule, which is if distance is close, the scale is big, and on the second row, our second rule. And for the third rule, you will see no antecedent or no graph from input layer is here, but we only have one in output, and this is the actual aggregated output graph for all your rules in here. And one thing that we will notice immediately is system is not behaving as we want to do. Of course, it's changed scale from big to small, depending on our distance, but it only changes within a small range, like from 1.33 to 0.67. And we don't want this behavior. We want it to go from 2 to 0. And the reason that we are having this issue is the way that we define the settings of this input system. By default, implication method is production and product, and the aggregation method is probabilistic OR method. And for this system, this does not solve our issue. What we want is having the minimum as implication method, and for the falsification we can use something like middle of maxima. And if we bake the system again and let's save it, we can change our distance and you will immediately see how it affects our outcome. And this is actually the result that we want to have from this system. And yeah, everything looks fine. We can save it and go back to our level and go back to our fuzzy cube. And this is not something fancy, it's just a simple cube blueprint that I created and placed into level. And in here, we want to have two different variables. One is distance from layer, and the other one is scale of cube. Let's compile and save. And let's first try to get the distance from player, and to do that we can get the player character and call the get distance to function. And our target is self and other actor is the player character, and we can get the distance and write it to it. And for applying the scale, let's get the scale of cube variable. And from scale components, we can say set relative scale 3D. And yeah, this is the blueprint setup that required. So you may ask, okay, you set the distance from player and you are not setting scale of the cube, or there's no reference of fuzzy logic. And you are right. For that, we need to add a new component, fuzzy logic component, and let's name them as fuzzy logic. And actually, we have several other ways of running fuzzy logic systems. Like you will find that there is evaluate fuzzy logic system function in here. You can directly set a system and provide inputs and read outputs from it, or you can derive your blueprint from FL evaluator interface. But the simplest one is using this component, and I also added some examples using the other ways of evaluating a fuzzy logic system in the demonstration level. So you can go check them out, but yeah, this is the way I recommend you to do that. And in your components, you can select a fuzzy logic system that you want to evaluate. In our case, it's FLS_tutorial. And you will notice that we added some input bindings and output bindings. And what are those is these are the variables that we define in the input layer, in the output layer. And the component is basically ask you to pick a property for the distance variable, and we can click and select distance from player. And for the scale, we can select scale of cube. And after that, we can compile and save it, and everything is fine. For note, there's evaluation type you will see in here. Two types of evaluations are available, one synchronous and parallel. I would recommend you to use parallel if you are running systems like over 200 or 400 systems. It's better to use parallel, but otherwise keep with synchronous as long as you don't get any optimization issue. And this in here you will see a refresh system variables tick box, and what it does basically, if you edit something on the FLS tutorial system, like adding a new variable, you can click this system variable, so it will show up in here, and or if you remove anything, it will also refresh. So it's just a refresh for those input and output bindings. All right, so yeah, it looks fine and everything should work. If we play our game, you will see if I get far away from the cube will get smaller, and if I get closer, the cube will get bigger. And yeah, let's say we don't like this behavior, it gets smaller really quickly, and we want to give some more tolerance. We can go our system and edit our variables, edit our fuzzy sets, and let's edit it so we will count as 100% close as 400. And oh, yeah, and we will count 1,500 as the point where close is not relevant anymore, and 500 as the closest. In here also I can make this change, so we kinda expanded and shifted the whole graph, and we can bake it again and save it. And when we go back to our level, you will see that our system is behaving completely different. So it's really easy to tweak the value. That, yeah, for this case, there may be a simpler way of doing that with using curve mappings or mathematical equations. But again, as I said, if you go and check some demonstration fuzzy logic systems in here, and let's actually do that, you will find out, for example, we have this fuzzy shop in here. And if you play it and go to the fuzzy shop, you will see at the left side we have a bunch of stats, and if we change them, you will notice that the values, the price tags are changing depending on our stats. So if we don't have that much luck, the prices go high for us. But if we have luck, the prices go down. And also, for example, if we are too low in terms of morale, the prices go up for us. And we have lower rhetoric, it goes even higher. But if we have high rhetoric, it drops. So yeah. And if we check the fuzzy logic system for it, let's do that. You will see that in here, this is the complex fuzzy logic system. So it's probably the most complex get you can get with this kind of systems. You will see we have bunch of stats in the input layer, and we have a hidden layer in here, and then the output layer, and all the fuzzy sets are defined in a similar fashion. Uh, and for our rule sets, you will see that rules like if charisma is low, then impression is bad. For input layer to layer 2, which is a hidden layer, and from the layer 2 to output layer, we have rules like if impression is awful, then price is high. So you can use a bunch of variables to affect more simpler or more compact variables, and with those more compact variables you can edit the prices. So in future, if you want to introduce an if stat and you want that stat also to affect the system itself, you can just add an if stat in here and add rules for it, and you will say, I don't know, maybe you made a stat like stamina, and if stamina is high, then the impression is good. And yeah, you don't need to care about anything else. The system will include that one too. And yeah, that was it probably. Oh, one last thing I would like to tell you about this. In When you select a layer, maybe it's better to show it in here. When you select a layer, you will see separate settings for them. So one layer can have complete different properties than the other layer in the same system. So it's pretty flexible, and like two of those values are maybe worth explaining what they are. So most of the time when defaultification, you will have some iteration level. So this accuracy is the the number of iterations. For example, for centrate defaultification, we need to run an integration operation. So to take that integration, if we select like midpoint or Simpsons, we are making some iteration to calculate that. And this accuracy is the amount of that iteration. So the lower accuracy will make the system evaluate faster, but it will also be less accurate. And the higher accuracy will make system go slower, but it will be much more accurate. So it's always a good practice to search for a sweet spot for that. So if we open our inspector and select our tutorial asset, you will see 75 is really good. But if we have a lower accuracy like 8 and bake it, you will see when I change the distance, the scale is like stepping for huge values, like from 0.38 to 0.62 with one small adjustment. But if I keep it on 75, you will see it's much more like interpolated value, much more responsive. And use parallel rule implication is this tick box is like if you enable this, all these rules you have will be evaluated in parallel. And for example, in here we have a considerable amount of variable, not that much actually, but if you have like 1,000 or hundreds of rules, you can call this use parallel rule implication to run all this rule in parallel. But keep in mind, it's not really there is something that eats from your performance. These rules are simply just converted to a set of instructions. They are really optimized. So yeah, unless you have like 1,000 or 500 of rules, there are no point of using this tick box, I guess. And yeah, additionally, you can export or import system. And let's actually export a system, this tutorial system in here. This window will open your saved folder in your project, and you can just save it as fls_tutorial. And if you go to folder, or let's make a new system in our demonstration. if it is new tutorial, and if we open it and we want the import system, we can click. Also, we can right click and select edit with Notepad to see what this system it looks like in a JSON format. So you can also edit the system in here. And after that, if you import it, you will see the entire system is just imported as if it is. So it's a good way to share the system with your colleagues if you don't want to use it using the assets or all that reference things. And also it's a good way to back up your systems before making a crucial change on them. And yeah, that's it. Thank you for listening to me, and I hope you enjoy the plugin if you buy it, and I hope it works for your project. And yeah, for lastly, I'm open to any feedback, so if you have any issues or any requests, feel free to reach me and tell me what your problems or feedbacks, anything. And yeah, have a great day. Bye bye.